Welcome to Roby's workshop. I've got a project inside and I'm waiting on glue to dry and finish to arrive. So what are we gonna do? We're gonna start a new project. We're gonna ramp it up. Come on inside, let me show you what I got in mind. Home projects. A robot vac ramp. Well, when I said we're gonna ramp it up, I meant that quite literally. We're building a ramp for my robot vacuum cleaner. We have one that's dedicated to the upstairs part of the house. The problem is that the old part of the house, which is timber frame, is about 8 inches lower than the new part of the house, the addition, which is traditional framing. And we'd like the vacuum to get to both sides. So the ramp will allow it to go up that single step and get to both sides of the house, and that'll accomplish what we want it to. Now the oaks, they're wood floors, and we have taken great pains to have the old part of the house. We had those floors sanded and refinished. We installed new floors in the new room, and the floors match because they were all finished at the same time with the same finish. Now, we want this ramp to get as close to that as possible. So the first thing to do is we pick our species, which is oak. Now I have behind me here, this is quarter sawn white oak, and we're not using that. That's expensive stuff. This is designated for a vanity in the new master bathroom. Now over here, I have a few plain sawn boards. That's perfect for this application, but not those boards. What we are gonna do is we're gonna take some of this cutoff from the project that is ongoing. And that is why we're tackling this one. The shop is a little bit of a mess, but it's a mess with one species of wood. And we're currently waiting on some glue to dry on the old project, and I've got a special finish arriving for that one as well. So instead of just waiting and doing nothing, we're ramping it up. We're getting busy. So the first thing we have to do, let's go upstairs and let's take a look at this step and the hallway that goes through there so we have a better idea of what we're building. This is where the old meets the new. You're in the old part of the house, the timber frame part of the house. Behind me, behind this portal, that's the new addition, and that's conventional framing. This was a window, so it's very convenient just to open this up and make this the entrance into the new part of the house. Now, the difference in the floor, I've got a little less than 8 inches. And the width of the portal here is about 28. So we have two dimensions here to help us work this out. There's a couple things to consider though. When you look at these robot vacs, you have to have an angle a little less than 20 degrees. Otherwise, the front sensor activates and it considers it a wall. Additionally, you can't have a bump in the floor higher than 5/8 of an inch. Again, the front sensor activates and it thinks it's a wall. So with that, I think we've got enough that we can start to sketch out our ramp. So let's go down to the shop, start putting things together. Now we're gonna duplicate the floor pattern, the tongue and groove pattern. We got about 2 inches wide with a 1/4 inch groove in it. Now we'll do that on the table saw. But before we get started, let's talk about this geometry. I'd indicated we needed about 20 degrees and the height was 7 3/4. So if we do that, we end up with a geometry that looks like about 19.75 inches long. That's a little longer than I would like, but we really got to stay with that 20 degrees. Additionally, that's not the length of the field. The length of the field is actually 21 1/4. So we're gonna make it a little proud of that, probably go for 22. And that way we'll be under our 20 degrees. Keep in mind, it's not the flat that you're looking at, it is the angle. And when you do the angle, the distance gets longer. Well, it's time to get busy, and we work with rough cut in this shop, and the first step is always to the jointer. We need a flat face to start with. Everything starts there. After that, it's to the planer. That way we can get 2 parallel flat faces. After that, it's to the jointer. That'll give us a flat, square edge. But none of that helps unless the fence is squared. Make sure you check it. Things have a tendency to wander. Now we can rip this board to width. I want to point out that I'm lowering the blade here, but I'm not lowering it past the gullet. You need the gullet exposed. That will allow the blade to remove the sawdust from the cut. The additional benefit is there's less blade exposed, and that makes for a safer cut. But don't go any lower. If the blade is struggling to remove material, the quality of the cut will suffer. I'm just taking a little time to get my rolling stops set up, and then after that, we're ready to make the cut. We're focusing on tongues and grooves. Grooves first, and I have my dado stack in the saw at 1/4 of an inch. Now, I want these grooves to be centered, and the way we do that is we push the board through, turn it around, and push it through again. That way we know that we're perfectly centered on this flat right here. We're setting up to cut the tongue, and there's a number of adjustments that need to be made with regards to the fence and the blade height. Recall that when we cut the groove, we had a 1/4 inch dado stack installed in the saw, and we cut one side, flipped the board, and turned it around the other side. This ensures that we're centered, but we're a 1/4 inch strong on that groove. Consequently, we're going to have to sneak up on this and get the blade height just right so we get a slip fit without overshooting and having a loose fit. We still have the 1/4 inch dado stack in the saw, but I have a sacrificial fence now, and part of that blade is buried in the fence. I don't want that tongue too long. If it gets too long, it bottoms out in the groove, and then you see the gap in the surface. Don't be afraid to take a block plane and knock the corner off those tongues. That may be the difference between a slip fit and frustration. I've got my boards how I want them. I like the variation of color and texture. I think this will work out just fine. Now, we're getting ready to glue things up, and that's why I've got things set up here accordingly, and I've got a few other things I need to get a hold of, and we'll start. I do want to mention, we've got 22 inches and 3/4. That puts us shy of this, what I would call a defect right there. Bear in mind though, we've got a very steep angle to cut into this field so that it gets close to the floor. I don't think that this is going to be a problem at all. Let me get a few other things. We'll get this glued up. The entire glue up took about 5 minutes, and that is nothing to complain about. However, in a podcast, that is an eternity. So I will go ahead and narrate this, but I'm going to skip through the various segments in order to save time. Now that my boards are arranged how I want them, I will put 1 bead of glue on either side of the tongue. Once my glue's in place, I'll go ahead and marry them up. I don't want to be fighting slightly dry glue when it's time to assemble the full field. We'll do them one at a time. Well, the last board is glued up and I'm setting the field in place. Now I want to get my clamps snug. I don't want to really torque them down just yet. I have a clamp that I need to put on top before I really tighten it up. This goes a long way to making sure that your overall field stays flat. Well, I am out of the clamps and I'm going to knock this down with an 80 grit. My objective is to get rid of what's left of the squeeze out. I've knocked out most of it with a scraper, but I've still got some here. After I knock this thing down, I'm going to the drum sander to make sure everything is leveled out and perfect. Then I'll come back here. That's 120. We'll go ahead and knock it back down over here with my random orbital, 120 all the way up to 220. This way, this squeeze out right here doesn't clog up my belts. I tell you what, set of paper on that drum sander versus a couple of these discs, there's no comparison. When you're sanding off the remaining glue, take a look for bar marks. Bar marks are where the steel bar comes in contact with the wood and when there's a little bit of moisture. If it's green wood, it'll happen there. If there's glue, the moisture in the glue will cause it to happen. What you're seeing is called iron staining, and that's where the tannins in the wood react with the iron that it's in contact with, and that usually creates either a black or a blue-black mark. This reaction is time and moisture dependent. The more you have of either one, the larger the mark and the deeper the mark will be.
A lot of times people will put a plastic shim or something between the iron and the wood to keep this from happening. It's your choice. If you break it out of the clamps in an hour, usually the mark is not too bad. We'll square up one end with the track saw and then follow up on the table saw to do the other side.
Well, my bandsaw veneering fence is pulling double duty. We're going to use it here to stabilize this board as we pass it through the blade. I need that 20-degree angle right here so that we can set our board on the floor. And remember, we only have 5/8 of an inch that this robot vac can jump over. I'm shooting for 1/4, and that's the gap I've got right there. In addition, we're going to take this edge to the router table after we cut it, and we're going to round that over. Well, I think this edge is coming along pretty nicely. Once we get a little sandpaper on it, I think it'll do just fine. Now the other end up here butts up against a bull nose. It's a 1-inch diameter. That's the end board on the step. And I don't have a 1-inch diameter cove bit. I've got a 1 1/4. We're going to make it work. I think it's going to be fine. Now I've got it set in there to give me another 1/4 inch on top. We're going to make this cut, and then we're going to come back and clean that up with the same bullnose bit we have down here.
We're going to make this in a couple of passes. I don't think we can hog out that much material without bogging down the bit, and we'll probably have burn marks as a result. So I figure 3 passes, 2 to get to where we want to be and 1 final pass to clean it up.
Our ramp is going to get a few edges right here, and I will take these to the router table. We'll round over these edges so they're not quite so sharp. We'll also take the time to round over the fronts right here, and I'll take a washer right there, make my mark. We'll go over to my oscillating belt sander and we'll just sand them down. That's the simplest and quickest way to do it. Now, the attachment, simpler still. We will just drill out some holes and attach these with a little bit of glue and screws.
Before we attach the rails, I'm going to round over the edges with a 1/4 inch round over bit.
I'm getting ready to put my side pieces on, and I've got this one gripped down. It's in place pretty good. I wanted to use 3 screws, and with this you need to countersink it, because if you don't, you stand a chance of taking the head of this and popping it right off in this oak, because this oak is actually stronger than your screw is. You also want to pre-drill it. Now, when I pre-drill oak, I make sure that my bit is at minimum the same diameter as the shaft. The threads will do all you need it to do. If you don't pre-drill, again, you're going to pop this thing off in the middle and it won't be where you want it. So with heavier woods, it's always good to countersink and pre-drill. Well, it's time to consider the feet. There are going to be 3 of them. Tripods don't wobble. I've got 2 that are going to be up front, 1 in the back. Now, I have chosen this particular foot right here. It's got a wide base, which I like. I can take some non-skid, stick it on top of it, and it won't move much. And this is heavy enough that I think it's going to stay put. It's also got a 3/8 thread on it, so it's adjustable. And if I use a T-nut, I can put that in there and things are great. Now, this is going to be at a 20-degree angle. So whatever foot we cut for this, whatever receives this T-nut has to have a 20-degree angle on this. That's why my fence is here. That's why I have this piece right here. We are going to cut this with a 20-degree angle so we can get a flat surface, but not yet. We have some things to do first, and it's going to become apparent why. So let's go over to the bench and let's start looking at how this T-nut interfaces with this piece of wood. Well, I've got my T-nut installed here on a piece of scrap. I wanted to see how it goes in, wanted to test this thing out first before I started talking about it. And there are 7 holes here. 7 holes have to be drilled out, and they're not all drilled out at the same time. So I thought about this, and I was using this piece is not slanted at all, and this one is. Installing all this on a piece that is not going to be square to the surface was a little bit too much. So we are going to do everything we need to do to install a T-nut first, then we're going to come back and cut this 20-degree angle on our feet.
We'll cut the shaft for the center first, and that's a 7/16 inch bit. We'll put the T-nut in place and give it a tap. That'll mark the prongs. We use a 3/32 inch bit to drill out the prong holes. After we've drilled out our 3 holes, we will install the T-nut. That's going to require some persuasion. This is as tight as that T-nut is ever going to be. If we don't want it to fall out over the long term, we need to drill holes for screws around the perimeter. I generally locate the middle of the flat on the sides, not the prongs. I'll install a very small screw in that hole to keep the T-nut from ever slipping out. Now that is a 3/8 number 6 flathead screw. It'll never come out now. Now we can cut our 20-degree angle. This piece is very small, so instead of trying to hold on to it with my fingers, I have actually screwed it to the fence. This allows me to keep my hands clear. We'll rip it to width on the table saw. It's still a small piece, so we'll use our push stick here. We'll make our final cuts on the compound miter saw, and then we'll have our pieces ready to install. This looks a little kludgy, but I promise you, once I apply pressure to that little piece right there, it's gonna move. It's a relatively snug fit between the front and back cleat. I want the edge set at about 1 to 1.5 inches inboard. It doesn't matter, it just needs to be consistent with the other one. I'll use a number 2 parallel clamp to hold it in place.
The third leg is complex. I want a single point to connect it because I don't want to generate a cross-grain situation. But yet I know for a fact somebody is going to put their foot in the wrong place and this whole panel is going to tip. So I've got to protect the low information guy from doing that particular thing. We're going to start with a connection point, and as we evolve through this sequence, you're going to see what I'm after. I can't explain it right here, but let's talk about this single point connection. I am going to use a T-nut, but it's going to be a reverse from the previous. In other words, I'm going to bury the head of the T-nut inside the connection. And the connection is going to be this right here. We're going to use glue in the same way we did before, and we're going to use a Forstner bit to clean out the top of this, a regular bit to clean out the area for the barrel, and then the small bit to clean out the area for the spurs. After we get it all cleaned out, we'll install the T-nut in the scrap, cut it to size, and then glue it in place. This is one of those interesting cuts. I have made a mark right here, but we want to be parallel to this line, so I actually have to take this and move him up to be parallel and hold him in place while I make the cut. Now, one of the tricks is you want that edge to be just below the surface. I need to touch more because you want those prongs tight.
Do not change your drill settings before you drill the barrel out. If you leave them alone, you can change the bit and the holes will line up perfectly. A few taps to mark the prongs, and then we will drill out the holes so they will set properly.
I'm going to use a stopped cut here, and there are actually benefits to doing it this way, and they'll show up at the compound miter saw. The benefit of having this extra bit of this wood here is I have something to hold on to on this side. Well, after all that, we still have to set our T-nut, and I want to line up my spurs so that it fits in, and that's easy enough to do. Right now I'm pressing on it, it won't go in. The spurs will actually grab on this oak. Now, I'm very close and I know I'm set. This small piece, and I'm not really intending to beat on it a whole lot, but you have an alternative. Take one of the nuts that you were going to use to secure your piece, a smaller one, so you don't have to turn it as much, and then you can literally just screw it into place. And I find that that is a really good alternative, especially with small parts. Now you might have to put this in a vise to get a good grip on it, but that's pretty good. And I can rub my finger past this tip right here and it is flush. So I know that this is holding up tight. Now that should stay in place long enough for the glue to set. And because this front edge is so tight, it is not going to fall out of place because the barrel inside the wood is going to hold it in place. And this spur right here that is buried deep is going to keep it from turning. This is a really good technique for taking a T-nut like that and making it just totally disappear. The only thing I'm trying to show, I've got a line here and I've got a mark right there that centers up on this, and I just want to get close. I don't have to get perfect. And that isn't the side that goes in place. It is that side. So when we put our glue on there, we need to keep that in mind. That should be enough. Go ahead and put him in place. Now, this is where things are slickery and things could move. We'll be watching this pretty close. That's on it. We'll let that cook for a while.
Now that we have our connection, let's take a look at the leg.
Well, this is my template, and this is my design right here. And we'll go ahead and put that up right over there. What I want to do is I want to secure this through this hole, a bolt go up to secure to the platform. And I want to put a T-nut on the bottom here in this recess to put my foot. And that is how we're going to transfer the load vertically straight down through to the floor. Now, if somebody should step on one side or the other, well, we are secured at these 2 points, and a tip will put this on the ground, and we can transfer our load that way. Second, we do have a problem front to back, but I have a bullnose over here, and I have 2 non-skid feet over there. So I think we're good in that respect. Now, this is a small piece. So when you look at it, you're going to look at this and you're going to see if one side isn't just like the other side, the imperfections are going to be pretty visible. So we're going to use the Shaper Origin, which is a very good machine with regards to cutting precisely. And I'm setting up a jig now, so give me a minute and we'll get after it.
It took longer to build the jig than it did to make the piece, and sometimes that's part of it. But if you're going to achieve the accuracy, you have to have all the pieces in place. There are a few other things we need to do though, and we'll start at the drill press. There is a sequence to things, and before we put any tapers on the legs so that it matches up with the floor and the ramp, we need to drill the hole right there in top. Otherwise, we'll be fighting an angle on the drill press that I don't want to fight. And now we'll go ahead and get the other side. This is for the foot.
One might think that it takes that the other side, the bottom, gets the taper, but that's square. It's this side that gets the taper. And I'll take 2 passes at this to get it right. This leg turned out real nice. It fits in just right. When I put that bolt through, I've got a hair here and a hair here. The leg over here, another just very close on this side. Center leg keeps it from wobbling. I've got 3 points of contact, but these are very close. If someone should step here or here while this is turned over, the load will transfer and the piece will be saved and it won't fall over. This was a good add. Now, we have sanded this whole thing down to 220, and I have taken the tack cloth and I've wiped it off everywhere. It's time to think about some color. I was a little worried about this because I was facing the aspect of having to match it myself, but I contacted the fella that put in that floor for us, and he said, I have some left, and this is what it is. And he's given us some here to work with. So we're going to apply this according to the specification. Apply a coat, keep a wet edge, let it go for 5 to 15 minutes, and then wipe it off. Since it's the same stain, we're going to get the same color. We may not get the same intensity. So I'll be looking pretty closely at that, but I think we're gonna be okay. So after we do the bottom, then I'll turn it over, we'll do the top at that point. Now, after both sides are done, we have to wait 4 hours before we can apply the final finish coat, the polyurethane that protects it. So that will be the next day. Additionally, I'm not doing anything right now, not with these clothes on. I'm heading back up to the house to get on my duds. I'll see you in a minute.
I have a natural bristle brush and I'm going straight out of the can. That's not my preference and it's not good practice, but it is a small project. We'll start on the bottom. That way we can test out the finish to see how it behaves. And additionally, we will work very hard to keep as much of it off the sides and top as possible. We will completely coat the surface, let it set for about 15 to 20 minutes, and then we'll wipe it off. If we need a deeper, more intense color, we can put on a second coat, but I will tell you, we didn't. So this is the only coat that was applied at the bottom, and the top gets a single coat as well. After about 15 to 20 minutes, we will wipe off the finish. I like to use white terry cloth rags for this. Then that makes them a disposable product, but if you buy them in bulk, they're not too expensive.
My thought process at this point, it might need to stay on a little longer, but I'm very happy with the end grain.
Application on the top is no different than the bottom. We'll give it a little bit more time, but all the steps are the same. This is a very small project, so I would suggest to use a finish that is already available, something from a previous project that you didn't use all of. This is an old can of Sealicel that I have, and fortunately I stored it correctly. I've got plenty here to use. Now I've got myself a piece of Scotch-Brite and I've wrapped a microfiber cloth around it, and that's what I'm using to apply it with. I am doing the feet first, going around the perimeter, and then I will do long, light strokes along the bottom. Now don't press hard on this, just let it rake the surface. If you press hard with general finishes, a lot of times it will leave streaks. So all you want to do is coat the surface and then even it out with the grain of the wood. We'll apply 2 coats to this to the entire surface of the project, and then we'll follow up with the final finish. We have 2 coats of Sealicel and we're following up with a coat of Armor Seal, semi-gloss. Now, a note about timing. General Finishes recommends 6 to 8 hours of dry time in optimal conditions. I would suggest to you that that is an air-conditioned shop at 72 degrees. If you were going to scuff this finish to apply the next one, and you should if you wait that long, it would be 24 hours. The reason for scuffing is that a urethane needs a mechanical bond to stick to itself. It's not like a lacquer or a shellac where it dissolves part of the next layer and then becomes one surface. This is multiple coats and they're independent unless they have a scuffed surface and create a mechanical bond. Now, I have read that if you apply another coat within 4 hours of the previous, the finish will adhere to itself. I guess the thought process is that the finish is green enough to accept another coat on top and maintain a good solid bond. I looked for this factual tidbit on the general specs for the finish and I did not find it anywhere, but I have seen it in the forums in several places. I've used this technique in the past on many a project and it does work. So consider your schedule and your risk tolerance when using this time accelerating procedure.
Well, there's a lot of finishing going on right now. I've got another project on the other side over there that's going on, but this one is done and I've put pads on the feet. Right now, the only thing I need to do is level it out so that I'm just off the ground here, and then we can take this upstairs and give it a try.
Well, I can't tell you how good it made me feel to see this vacuum go up the ramp, because I have another vacuum that didn't go up the ramp and would not go up the ramp. I would suggest the difference is there is a small wheel in the back of this unit, and that little wheel goes a long way for helping the unit go up. They all seem to go down pretty well, but they don't all go up.
Well, my friend here ran up the ramp, and I don't mind telling you, I'm a bit relieved. I didn't do a prototype for this project. I had a big hole in my schedule and a little bit of scrap lumber, so I just jumped right in. And it worked, and I'm very pleased with that. But there's a number of things I would change. The first thing is I would make it wider. There's a lot of bumping around in this thing to get down this ramp or up this ramp. A little bit wider would make the entry and exit a little easier. Second, I would make it longer, and there's a reason. The 20 degrees works for most vacs. When it goes up, this wheel engages here, this little wheel will engage, and these spring wheels right here will make the difference up. And if the angle is too large, these lose traction. That's the reason for the 20 degrees. But there's a problem. A lot of vacs, if they have a suction emptying mechanism from the end, they don't have this rear wheel. So as it goes up the ramp, this disengages, it doesn't roll, it drags. And the friction is too much for it to handle. So the robot disengages and backs back down again. I've got a vacuum cleaner that does exactly that, so check yours out. This particular solution may not work for you. So that about wraps it up for this episode. And if you like what you've seen, give me that like and subscribe. And I hope to see you next time in Roby's workshop.